Hello students, today we are going to study chain surveying. The direct measurement of a linear distance between two points using a chain is known as chain surveying. It means that if we want to measure the distance between two points with the help of a chain, then it is known as chain surveying. Now suppose that we have an area like this and we want to do the chain surveying of this area. So we will divide this entire area into two equal halves, that is one in this direction and one in this direction, and we can divide this area into two equal halves by one baseline which is shown here, that is this line. This line is known as baseline. Now the end stations of a baseline are known as main station, which is shown here, that is A and D, and all the external stations except main stations are known as subsidiary stations, that is B, C and E. They are known as subsidiary stations. Now the line joining the main station and subsidiary station or two subsidiary stations are known as main line, that is shown here. Now we need to transfer the subsidiary stations to the baseline, so that we need to draw a tie line from every subsidiary station in perpendicular direction like this, that is shown here, that is shown here and that is shown here. And the point where tie line meets the baseline is known as tie station, and it is represented by small b, small e and small c. Now in chain surveying, to get any information we need to transfer that point to the baseline so that we can get the exact information about that point. Now suppose that here a tree is present. Now we want the information of this tree, so that we need to draw one offset that is shown here. Now the information of this tree will reach to the tie line, and from tie line it will reach to the baseline. So in this way we will get the information of tree. And suppose that there will be a pond which is shown here. Now to get the information of this pond we need to draw the offset which is shown here, that will be like this. So in GATE exam they had asked a question that an offset can be perpendicular, oblique, both, and one more option. So generally an offset can be either perpendicular or can be oblique, but the most appropriate answer is oblique offset. So you have to select the oblique option. Now we will get all the informations of subsidiary station as well as tree, pond, etc. Now we want to check our whole chain surveying, so we need to construct a check line between two subsidiary stations. Okay, that is this line. Now we will measure the distance between E and C station on the ground, and we can convert that distance with the help of scale which we had used for this drawing purpose. Okay, and we will measure this distance EC on our sheet. So if both the distances are same, then our whole work is accurate and correct. And if the both distance, there is distance on sheet as well as distance on ground which we had converted according to our scale is not same, so our chain surveying is wrong and we need to repeat the process once again. Now one note is there that chaining is the measurement of distance between 2 points, whereas ranging is defined as aligning the chain between two extremities along a straight line. It means that chaining is only the measurement of distance between 2 points, that is this distance, whereas ranging is the aligning of the different points along a straight line. It means that if 3 points are present like this, that is A, B and C, and if we want to do the ranging of these 3 points, then by ranging we will bring all the points in a particular straight line, and that will be known as ranging. So ranging is defined as aligning the chain between two extremities along a straight line. That is all about the chain surveying. Now we will see the various terms which will be used in chain surveying. Now the first one is survey station, a control point on the field from where information about the area under survey is collected in the form of linear distances known as survey stations. It means that these are known as control points from where information about the area under survey is collected. Now, major control points or major survey stations are marked on the outer boundary of area, that is main stations as well as subsidiary stations. So, they are known as major control points, whereas minor control points are marked inside the survey area, that is tie station, which is shown here. They are known as minor control points. Now, the next one is survey line. A line joining the two control points or a control point with baseline is known as survey line. Here, this main line is known as survey line. This tie line is known as survey line. This offset is known as survey line. This check line is known as survey line. And this baseline is also known as survey line. That is, all the lines are known as survey lines. Now, what is baseline? It is the reference line of survey which connects two far distant major control points, which we had already seen, that is this line between the two extremities, which is marked here by A and D, like this. The baseline should be selected in such a way that it can cover most of the survey area. The endpoints of a baseline are known as main station. It means that A and D are known as main stations. Now the next one is main line. The survey line which connects the two major control points along the external boundary of survey area is known as main line. It means that the line which connects the main station with subsidiary stations, or the line which connects two subsidiary stations, are known as main line. So these lines are known as main lines. The control points on external boundary except main stations are known as subsidiary station. It means that these stations are known as subsidiary stations. They are known as subsidiary stations. Now the tie line, the line which joins a subsidiary station with baseline, is known as tie line. Now we want to transfer this subsidiary station to the baseline, so we need to draw a tie line here, and the point where tie line meets the baseline, that station is known as tie station. So I had written here the point or station on baseline where tie line meets, known as tie stations. Similarly, offset, the lateral distance of a point or any ground feature from a survey line, is known as offset. Now we had drawn an offset like this, that is tie line, and there is one tree, and this line is known as offset. Similarly, there is one tie line and there is a pond, and to get the information of this pond, we will draw the offset which is shown here. Now, offset can be oblique or can be perpendicular. Now, the next one is check line. Check line or proof line is used to check the accuracy of survey work carried out on field and its plotation on paper. We had already seen a check line from station E to station C like this. This is known as check line. The length of check line on field must agree its corresponding dimension on the drawing sheet. So if these two distances are same, then we had computed or we had done the change surveying accurately as well as correctly, otherwise we need to repeat the whole procedure once again. Generally, check line is drawn between two subsidiary stations inside the survey area. Almost all the times, check line is generally drawn between two subsidiary stations because between two main stations there will be only one line, that is only baseline. Now, how can we measure the perpendicular offset? Now, for the measurement of perpendicular offset, we generally use cross staff as well as prism as well as optical square. Now, cross staff, it is an instrument consisting of a frame or box with two pairs of vertical slit mounted on a rod or pole to draw on an object from survey line. Now, for the drawing of perpendicular offset or inclined offset, we will use cross staff. Now, it is generally of three types. First one is open cross staff, next one is French cross staff, and the last one is adjustable cross staff. Now, we will see the first type of cross staff, that is open cross staff. Now, open cross staff is shown like this, having two pairs of vertical slit, that is one pair like this and another pair like this. Now, in one pair there will be one eyepiece and there will be one objective. Similarly, on another side there will be an eyepiece and there will be an objective. Now, if we want to draw the perpendicular offset, then we need to use the open cross staff. Suppose that this is the baseline and here an object is shown and we need to draw this perpendicular offset. Now we will take the open cross staff and slowly moving on this baseline, and at particular interval we will see from this face, that is in perpendicular direction. Now if this point is seen, then we will measure the horizontal distance, otherwise we need to move to the baseline ahead. Now suppose that at this point when we see from this eyepiece, then this point is bisected, so we will measure the distance, that is suppose that D and E. So we will measure the distance D and E and we can easily plot the perpendicular offset by the use of open cross staff. So open cross staff is provided with two pairs of vertical slits giving two lines of sight of right angle to each other. The object is seen by moving the open cross staff on survey line, which is shown here. Now if the object is not seen, then the cross staff is moved backward or forward till the line of sight also passes through the point. Till the line of sight also passes through the point. That is known as open cross staff. So with the help of open cross staff, it is possible to set out only 90-degree offset. Now we can move to the next type of cross staff, that is French cross staff. Now it consists of hollow octagonal box which is shown here. Now vertical sighting sights are cut in the middle of each face. In the middle of each face there will be vertical sighting sites like this. Now generally it have four pairs of vertical slits. One is like this, second is like this, third is like this, and fourth is like this. So it is possible to set out angles of either 45-degree or 90-degree with the instrument. It means that we can easily set out 45-degree as well as 90-degree offset with the help of French cross staff. Now we can move to the next type of cross staff, that is adjustable cross staff. Now it consists of two cylinders of equal diameter placed one on top of each other, which is shown here. That is one cylinder here and another movable cylinder in this portion. Now this portion is fixed to the tripod, so it will not move, and here is one eyepiece. Now with the help of adjustable cross staff we can set out any angle offset. So with the help of open cross staff we can set out only perpendicular offset, that is 90-degree offset. With the help of French cross staff we can set 45-degree as well as 90-degree offset, and with the help of adjustable cross staff we can set any angle offset. That is all about the cross staff. Now we can see prism square or optical square. Prism square is shown here and the optical square is shown here. Now in prism square the reflecting faces is at an angle of 45-degree and the reflecting surfaces are fixed in case of prism. So here is one eyepiece and here is one objective. Now suppose that there will be one object which is shown here. Now if we want to see this object, then the line of sight will be like this, and it will reflect from this reflecting surface like this, and it will again reflect from this reflecting surface like this. So in prism there will be two total internal reflection which is like this, and we can easily determine the perpendicular object which is shown here by just seeing from this eyepiece. Now in optical square the principle is same as that of prism square, but in optical square the adjustable mirrors are present in place of fixed reflecting surfaces. So after every measurement we need to make the angle of both the adjustable mirror at 45 degrees so that we can easily see the object which is at 90 degree from our line of sight. So we need to adjust the mirror in case of optical square. So prism square is far better option as compared to optical square. Now, both instruments work on the reflection of incident ray at right angle. The only difference is that the reflecting surfaces are fixed in prism, whereas they are adjustable in optical square. So prism square is more precise and modern equipment to draw a perpendicular offset. That's why prism square is generally used for the plotation or for the drawing of perpendicular offset. That is all about the prism square or optical square. Now the next one is cross staff surveying. Now with the help of cross staff we generally perform the cross staff surveying. Now in cross staff surveying, to calculate the linear distances and area through plotting perpendicular survey lines, we generally do the cross staff surveying. Now in this method of surveying, entire field is divided into number of triangles and trapezoids. Now the cross staff surveying is generally done to calculate the linear distances and area through plotting perpendicular survey lines, and in this method the entire field is divided into number of triangles as well as number of trapezoids. Now one data is given here, that is plot the following cross staff survey to a field A, B, C, D, E, F, G and calculate its area. Now a data is shown here which we collected from the cross staff surveying. Now we want to calculate the area of this entire field. So we can just plot this data on our sheet like this. Suppose that this is the baseline. Okay. Now the distance which is given in the question is 0 meter here as well as 600 meter here. Now 450, 310, 230, 150, 80 and 0. Now in this direction an offset of 20 meter is shown, that is 20, whose name is B. Similarly at 310 there will be an offset of 40 whose name is C. Similarly at 450 there will be an offset of 20 which is shown here, that is 20, whose name is E. Similarly at 230 there will be an offset of 50 whose name is F. Similarly at 150 there will be an offset of 10 whose name is G, which is shown here. Now we will just join all these lines with the help of straight lines like this, and we will get the shape as triangles, trapezoids. Now we will just name all these areas, that is first area, second area, third area, fourth area, fifth area, sixth area, and the last one is seventh area. Now after addition of all these areas we will get the total area of the field, which will be equivalent to area of first portion plus area of second portion, so on up to area of seventh portion. Now we will just put all these values, that is area of first portion will be equals to half into base into height. The base will be equivalent to 80 and the height will be equivalent to 20. Similarly we can compute the area of second portion, which will be equivalent to half into sum of parallel sides, that is 20 plus 40 into base, which will be equivalent to 310 minus 80, that will be the second area, plus third area, which will be equals to half into base will be equivalent to 600 minus 450 into height, which will be equivalent to 40. Similarly area of fourth portion, which will be triangle, so its area will be equals to half into base will be equivalent to 600 minus 450 and the height will be equals to 20. Similarly area of fifth portion, it will be equivalent to half sum of parallel side, that is 20 plus 50 into base, that is 450 minus 230. Similarly area of sixth portion, that is area of sixth portion can be represented as half of sum of parallel side, that is 50 plus 20, sorry 50 plus 10 into base will be equivalent to 230 minus 150 plus area of seventh and the last portion, which is triangular in shape, and its area will be equals to half into base will be equivalent to 150 and height will be equals to 10. After addition of all these areas you will get total area as 25850 meter square. That will be the total area according to the cross staff surveying. That is all about the chain surveying. Thank you very much, students.